In 1997, people counted around 800,000 dams on rivers worldwide, with approximately 40,000 of them standing taller than 49 feet. Since then, of course, a lot has changed, and the number of dams has grown significantly, with many of them reaching even greater heights. Just in case, let me explain what dams are. I mean, you never know, someone might not have come across them. So this structure blocks a waterway and creates two reservoirs. One upstream where water accumulates, and one downstream where water flows out from the upper one. This is usually how electricity is generated. The dam is built in such a way that the water in these two reservoirs is usually at different levels. The difference between them can be just a few feet or even a few hundred feet. For instance, the tallest dam in the world, the Jinping 1 hydropower station, which is of course in China, creates a height drop of a whopping 1,017 feet. And that's where the problem lies. A height difference like that turns into a serious problem for ships navigating the water route. To deal with it, a heavy ship has to go up or down by a few hundred feet, but how can you do that? There are plenty of solutions out there, but it looks like China might just have the best one. Today, there are at least 7,000 truly massive dams worldwide. They're all marked on this map, and the darker the color, the more dams are in that area. However, if you take a look at the list of the largest dams in the world, you'll see that most of them are actually in China. And sometimes they're built so high up and are themselves so massive that China's had to solve what seemed like an impossible problem. China has to guide ships through mountains. Literally. Honestly, I need coffee to wrap my head around this, so I'm off to make some. Just an unobtrusive reminder to do something if you forget. And thanks for understanding my desire to, well, you know what. To begin with, let's figure out how exactly a ship gets transported through a dam. Typically, this involves special locks that are built along with the dams. First, boats and ships travel along the waterway, entering a lock, which is a large chamber in the water with gates that move at both ends. Then the vessels wait for a while until a valve opens, letting water flow from one lock to another. Sometimes, if there's just one lock, the water flows straight into the next reservoir. The idea is that physics takes care of raising or lowering the boat automatically depending on the water level. The boats move on to the next lock and so on until they reach the end of the dam and lock system. A series of locks lets vessels sort of step up or down a river or canal from one water level to another. This way, people can also make huge ships pass through shallow or too steep sections of rivers with rapids, going up and down rivers much further than the natural terrain would allow. Locks can help overcome other natural obstacles like waterfalls or sandbars. The famous Panama Canal, by the way, works just like that. Its operation is based on locks and chambers where the water rises and falls along with the ship. But it's not a one-size-fits-all solution. Locks have a height limit on how high they can lift a vessel, so in some cases when a significant height needs to be crossed, people install a whole series of locks one after another. The vessel goes up or down like on stairs. But even this system might not be enough, and in China they found some completely different solutions. Let's start with the famous Three Gorges Dam, also known as the Chinese Miracle, on the Yangtze River. It's considered one of the largest engineering projects in the world, built with 988 million cubic feet of concrete. The dam, along with its hydroelectric power station, was commissioned back in 2003, but the main feature was yet to come. The structure was completed at the end of 2016, and it introduced a new type of lift, a hydraulic seesaw that can raise and lower ships by up to 370 feet to traverse the dam. The system, designed for vessels with a displacement of up to 3,000 metric tons, is a bit more complicated than traditional locks. Although they were used there first, the new ship lift raises and lowers boats using cables, a pool, motors, and simple gravity. Concrete counterweights along with water keep the system balanced, and high-tech safety stops do the same. The Chinese Three Gorges Corporation, which designed the lift together with German engineers, immediately stated after its opening that they expected several benefits from their creation. These include reduced energy consumption, increased cargo capacity along with passenger flow, reduced carbon emissions, and most importantly, time savings. The transition, which used to take 3 to 4 hours through the locks, now takes just 40 minutes. And during those 40 minutes, the ship rises to a height more than twice the height of the Statue of Liberty. I hope you're impressed, because I am. How does it work? Well, first the ship enters the lift, or rather the ship chamber. Its depth is 9 feet and its height is 59 feet, so there's actually a limit to the ship's displacement. The chamber itself is made of reinforced concrete and is suspended by 256 cables attached to counterweights. When the counterweights drop, the chamber rises with the ship. At the highest point, the chamber levels with the water on the high side of the dam, the steel gates open, and the vessel exits the chamber. The lift is powered by 4 fixed screws called rotating locking rods. In case of an emergency, the screws which run along threaded guides get locked, and the chamber comes to a complete stop. Water can both be added to and drained from the chamber. Even though the lift mainly works by gravity, electric motors, like in an elevator, are used to keep it stable and safe. Actually, the main standout feature of the Three Gorges Dam ship lift is its focus on safety. Thanks to those 4 sets of symmetrically arranged drive mechanisms, the ship chamber is firmly held at 4 points, so no water movement inside can harm it. The risk of the chamber tipping over is kept to an absolute minimum. Engineers also added buffering and damping systems to the ship lift chamber to absorb shocks and vibrations. This means that even during an earthquake, the seismic forces would transfer to the tower's columns rather than causing the chamber to fall or any major accidents. That's pretty smart, considering there are about 430 earthquakes every year in China. And in the last 10 years, there have been 4,297 quakes with a magnitude of 4 or higher within 186 miles of China. Better safe than sorry. What else can I say about this Chinese engineering marvel? The size, elevation, and carrying capacity of the lift are about 1.5 to 3 times greater than those of several famous ship lifts in other countries. This lets China proudly call its ship lift at the Three Gorges Dam the biggest and most technologically advanced in the world. The only downside, it's still not big enough, so some of the larger ships still have to use the 5-tier locks at the dam. Over the past 2 decades, more than 993,000 vessels carrying about 12.24 million passengers have passed through the shipping locks in the upper reaches of the Yangtze River, China's longest river, so the lift was built in just the right spot. It's going to save a lot of time and money. Another hydroelectric power station I wanted to talk about today is Gupatan. It's located on the Wujiang River in Guizhou Province in southeastern China, and it's the biggest plant in a whole series of hydroelectric stations along the Wujiang. With a capacity of 3,000 megawatts, it plays a key role in the national project to transmit power from the west to the east. Today, though, it's not electricity we're interested in, but a new ship navigation system launched not so long ago in 2021. It allows ships displacing up to 500 tons to pass through the dam via a suspended aqueduct on the higher side, which connects to a massive ship lift. This lift lowers the ships down to much lower river levels on the other side. The ship lift is 653 feet tall, which is said to make it the tallest in the world. The structure's certainly mesmerizing, especially with ships passing through the aqueduct suspended 328 feet above the ground. But the most important thing is that it lets important commercial shipping continue. Huge cargo ships can go directly through the Guizhou Plateau. The project shortens the routes for domestic and international trade, connecting eastern and western cities of China through the country's inland regions. This navigation project is called the first to use a series of 3 ship lifts connected by 2 intermediate channels. The first and third lifts are considered the largest in the world with the highest lifting capacity. The second lift is also remarkable. It reaches a height of 417 feet, making it the tallest single lift in the world. In the end, the system shifts the ships between water levels that differ by 653 feet. Roughly the height of a 65-story building. The system's projected capacity is 2.9 million tons of cargo annually, and it took $777.5 million to build it all. Essentially, this entire massive structure, with the total length of 2 aqueducts, a navigation tunnel, and ship lifts being 1.4 miles, also acts as a kind of staircase. But instead of locks, there are vertical lifts, and the ship moves between them through the aqueducts. First, it enters the vertical ship lift at the upper reservoir, which lowers the ship by about 154 feet, to the navigable aqueduct. Then, over the navigable aqueduct, the vessel moves toward the second lift, passing through a tunnel right inside the mountain. After that, it keeps going until it reaches the highest lift in the system and the world, the one that stands 417 feet tall. After getting through this lift, or rather riding in a giant elevator, the vessel moves on along another navigable aqueduct, This one's open and looks like a concrete bridge. I think most of the photos of ships floating above the mountains were probably taken here. And finally, the ship arrives at the last lift, a vertical ship lift with a height of 236 feet. These are probably the most notable Chinese lifts to date. They're often called engineering wonders, but China isn't the only place where you can find such structures. The Streppy Thieu boat lift is located in the Central Canal in Belgium, near the town of Thieu in the municipality of La Ruelle. With a height difference of 240 feet between the upstream and downstream reaches, it became the highest boat lift in the world after its official opening in 2002, holding that title until the completion of the boat lift at the Three Gorges Dam in China. As you may recall, that project was finished in 2016, and the title of the highest passed to another lift. As for the Streppy Thieu, it was designed as part of the modernization program to replace the system of 2 gates and 4 52-foot lifts, which had been in place from 1888 to 1919. Yeah, it's that old. It was getting a bit outdated. Now the lift consists of 2 independent caissons with counterweights that move vertically between the upstream and downstream sections. According to Archimedes' principle, the caissons weigh the same whether they're loaded with the boat or just contain water. In practice, fluctuations in the water level mean that the weight of each caisson ranges between 7,200 and 8,400 tons. In general, the lift is open to vessels with a displacement of up to 1,350 tons. Each caisson is supported by 112 suspension cables and 32 control cables. These cables are 3.3 inches in diameter each. The vertically moving waterproof gates are designed to withstand an impact from a 2,000-ton vessel at 3 miles per hour. You never know, right? And on top of that, the provincial government is promoting the lift as a standalone tourist attraction. And I have to say, it's actually quite interesting. It took 20 years to build all this infrastructure, but it was worth it. Since 2002, the volume of traffic on the Streppy Thieu lift has increased from 30,000 tons per month to 200,000 tons. Considering that a barge with a capacity of 1,350 tons is equivalent to 90 trucks, this has significantly eased traffic on the highways of the Walloon region. Actually, the construction was necessary because the original canal became too small to meet the region's needs. The industry had developed too much. But now everyone's happy and everything's working. In 2021, 2.11 million tons of cargo passed through the Streppy Thieu lock. Anyway, let's look at something really unusual. For example, the ship lift built in 1976 at the Krasnoyarsk hydroelectric station on the Yenisei River near the town of Divnogorsk. It's literally the only ship lift in Russia. But what's interesting isn't just that, but the details of its structure. The lift consists of the outer harbor, the lower approach channel, the lift itself, and the turntable. The lift is a platform that moves along a track with a track gauge of 29 feet and has a gear drive. The movement is powered by electric traction. Yeah, they really transport ships by train here. To load the vessel onto the lift, the platform is lowered below the water level. The vessel enters the lift, and then the platform begins to move up the ramp, while the vessel is transported afloat. At the top, the platform with the vessel rolls onto a turntable, which moves it to another track, and then on that track, the platform descends into the upper reach below the water level. After that, the vessel can leave the lift and continue its journey. The estimated weight capacity of the whole structure is up to 1,500 tons, but it's considered one of a kind, with no counterparts anywhere in the world. Oh, and I almost forgot to mention that the total working length, including the underwater parts, is 4,954 feet. Actually, to really understand the scale of the structure, it's better to look at the lift when there are people next to it. The Krasnoyarsk hydroelectric power station is the second most powerful in Russia. Its gravity concrete dam is impressive. It's 3,500 feet long and 420 feet high. The ship lift is located on the left bank, right where it connects to the dam, and it works with it as part of the Krasnoyarsk water control system. Since the dam is 420 feet high, the lift helps vessels overcome a height difference of about 328 feet. Its construction was needed to restore navigation on the Yenisei River, which had been interrupted by the dam built in the riverbed. And this is, well, it's the Falkirk Wheel, and you might have already seen it. It's a pretty well-known structure from Scotland, but I just had to mention it in today's video, because this 115-foot tall construction is the only rotating boat lift in the world, which replaced 11 locks that used to be here. They were closed in 1933. This engineering marvel, awarded numerous prizes, transports ships between canals in massive gondolas, using as much energy as it would take to boil 8 kettles. You get it, right? The word marvel isn't an exaggeration. Naturally, the structure attracted tourists from all over the world, sparked a surge in popularity for the Scottish canals, and filled the people of Falkirk, where the wheel's located, with pride. The site chosen for the construction of the Falkirk wheel in the 1990s turned out to be quite a challenge for the engineers working on the project, because now it looks all nice and well kept. But back then, it was just a wasteland with a big puddle known as the Ernbrew Lake, about a half-mile from the locks. To bring the idea to life, they had to design a canal that stretched for an additional 0.6 miles, find a road, and build a new bridge under the Edinburgh-Glasgow railway line. Construction could only take place on Sundays because that's the only day the trains weren't running. Then a tunnel had to be dug under the Antonine Wall. Just so you know, that's a Roman fortification from 142 AD. Only after that could the engineers build the aqueduct, the Falkirk Wheel, to drop down 100 feet to the pool and then travel along and through Jubilee Lock to reach the Forth and Clyde Canal. Overall, this project was quite a headache. Besides, the designers had already decided to build an impressive, iconic structure of the 21st century to connect the canals, rather than just recreating the historic lock section. The old-school version was simply inconvenient. They had to spend the whole day working to open and close 44 lock gates to complete the journey between 2 canals. Meanwhile, the Falkirk Wheel lets vessels pass between 2 waterways in just a few minutes. The height of the structure is 115 feet, the same as 8 double-decker buses, and it's held together by more than 15,000 bolts. The design was inspired by the Celtic double-headed axe, the screws of a ship built in Clydebank, the ribcage of a whale, and the spine of a fish, all at once. But the key thing is the way it works. The lift has 2 gondolas. These are tanks that carry the boat, staying in the water between the Union and Forth and Clyde canals. Electric sensors monitor the water level in the gondolas to ensure they have equal weight, which is crucial for the wheel to work. Thanks to the equal weight, the gondolas stay perfectly stable, so the wheel requires very little energy to spin, and when the wheel starts turning, the gondolas are held in place by a system of gears and sensors. Without these mechanisms, the inertia created by the massive weight of the water would tip the gondolas over, and the miracle wouldn't happen. The wheel's been working fine since 2002. By the way, it was opened by the late Queen Elizabeth II herself. The biggest news from the past few days is that I was in such a rush and drank coffee right after brushing my teeth. It tasted awful. Marine Railway. You could say that ship lifts are a real engineering marvel. However, they build them everywhere, unlike marine railways, which are much rarer. For example, something like this exists in Canada, in Ontario, as part of the Trent-Severn Waterway. The lift is called Big Chute, and it's designed to move ships along a sloped track. It helps boats on special platforms overcome a height of about 59 feet. Besides, Big Chute's the only operational marine railway lift in North America and plays a key role in the Great Loop Route, which is 6,000 miles long. How does this thing work? The ships are floated onto a cradle about 80 feet long and 26 feet wide. The movement is powered by 4 electric motors, each with a capacity of 150 kilowatts, which pull the structure with cables. What's interesting is that the mini railroad track design has been improved, and in the new version, the load is distributed across double rails, which helps keep the platform horizontal. In short, there's nothing complicated about it. Besides being super handy, the lift is also a scenic spot on the Trent-Severn Waterway with picnic areas, restrooms, and trails. So it's easy to have a picnic here with an amazing view. Boat lift of 2 countries. About 30 miles from Berlin, you can also find a ship lift, but this isn't just some little one, it's the largest in the country. Built to move big modern barges along the canal connecting Germany and Poland. The structure measures 436 by 151 feet, stands 180 feet tall, and can handle vessels up to 361 feet long. As for lifting power, it can manage a weight equal to 50 blue whales or 1,600 elephants. A real beast of a machine. The lift mechanism raises ships to a height of 118 feet in mere minutes, letting them smoothly travel from the Polish port of Szczecin to Germany's capital. This concrete structure has become an essential aid to navigation, and despite the challenges the builders faced during construction, the lift continues to work efficiently. Record-breaking dam. Now let's take a look at the Three Gorges Dam from a different angle. It's the country's most expensive hydropower project, which has significantly increased the navigability of the Yangtze River and reduced the likelihood of flooding downstream. The dam has 34 generators that together produce an enormous amount of energy. It's truly a unique structure that holds several world records. For example, in 2023, the cargo turnover through the 5-tier locks at the Three Gorges Dam reached a record 1.91 billion tons. And that's just 1 year. The Yangtze River is a true golden waterway in China. By November 15, 2020, the Chinese project had generated an incredible 103.1 billion kilowatt-hours of clean electricity, setting a world record for the annual energy output of a single hydropower station. To give you an idea of how much this is, it's equivalent to the energy produced by burning 31.71 million tons of coal. And don't forget, the hydro plant works without waste. If we compare it to the same coal, it means that 86.71 million tons of CO2 and 20,600 tons of sulfur dioxide were avoided. In short, it's all pluses when it comes to energy production. What else can be said about the dam? The Three Gorges Dam is the largest water conservation project in the world with the highest flood control capacity. The total capacity of the reservoir is 10.4 trillion gallons, and most of this water is actually meant to save lives. How? It's simple. The Yangtze River's flow rate is increased so they can control the water in the upper reaches and also regulate the middle and lower stretches of the river. And I almost forgot to mention the construction. The dam has taken on the biggest part of the project load. In other words, this means the amount of work done and materials used. For example, the excavation for the main structure of the project is 35 billion gallons. The installation of rebar and steel structures amounts to 463,000 tons and 256,500 tons, respectively. Also, a huge amount of concrete was used for the dam, about 550,000 tons per month. It's just amazing how the dam is still holding up under all that weight. Did you remember to put a like? See you later.